I'm Alfredo, but you can call me Al. I'm a director of engineering at Hearst. I'm also a drummer, and I mainly consist of butter, garlic, and Parmesan cheese. You can find me on Twitter. I talk mostly about web development and performance, but also music and movies. And today, I would like to share my story about attending PerfMatters a year ago, and the learnings that I had, some of the attempts that were mostly unsuccessful, and the small accomplishments that felt incredibly huge to me. And regardless of what you've done before, for the next couple of days, we're all going to be here. You are going to learn a lot of new things or connect some dots on things that you already knew before. But in order to tell my story, we're going to have to rewind to last year. If you haven't heard of Hearst before, it's a media company with more than 360 businesses. Its major interests include magazines, TV networks, newspapers, and more. And some of the properties that you might have heard of before include Cosmopolitan, Esquire, and Elle, but there are a lot more. When I started at the company, there were considerably fewer properties, so it made sense for the code base to be separate. But as we added more sites, it was harder to maintain, deploy, and evolve. So we decided to consolidate all of the sites in one single application. That's 100 plus websites living in one application. This is awesome because it gave us a lot of control, but the additional responsibility that when we break something or decrease the performance of a shared component, it's spread across the whole platform, and it really hurts. So performance really matters for us. And last year, I found this little conference being posted on Twitter, so I convinced my boss to send me. And if I could describe it in one word, it was amazing. But in the back of my head, I kept thinking, how can I put all of this stuff that I'm learning right now into practice? Because the moment that my boss sent me, there's a return of investment expectation of what can I do when I'm back. So today, I wanted to talk about the two major conventional paths that are talked about when tackling performance. And the first one is to get the executive buy-in, right? We heard of this many times, of convincing the people that are making the decisions of where do we spend our time to put some time away for improving performance. And the first thing that you need to do, as we've heard, is to measure. We can use tools like Web Page Test and Lighthouse without making any code changes to test our sites across a variety of devices and speeds and see how we're doing. And we can also use, this is known as synthetic testing. And we can also use a small library like Perfume.js for doing the opposite of getting the same metrics, but from the real user devices. And once you have that data about your site, you can compare yourself to competitors, like what Rick mentioned, using the Crocs dashboard or HTTP archive or BigQuery. But there's also a site, think with Google, Test My Site, that you can use some of this same data. And they also have a performance calculator where you can put some variables and see the amount of money that you're losing, you're leaving on the table by not improving performance. And when I was showing this to the executives, I still had some slides left on my deck, but they stopped me and said, just go and do it. So now that we had that executive buy-in, me and a few other folks, we had to decide where do we start. There were so many different things that we could start optimizing, but based on our test, it was clear that the one to blame was JavaScript. And JavaScript is one thing that the community has agreed that is both the best and the worst thing to happen to the web. And that's very clear. And this is where we were standing before. We had one bundle served for both our homepage and feed pages that it was 360 kilobytes uncompressed. And on a mobile device with 3G speeds, it was taking up to 2 seconds to load, and then it would execute and clog the main thread, as you can see by that rectangle of pink. And this bubbled up to our load time of 13 seconds, almost 13 and a half. So now that we had some data, we start working. But instead of focusing on different technologies or approaches, we took a step back and asked ourselves a question. Does the user need this right now? And you can use the page lifecycle, document load, window load to defer things, but a better approach is to infer by user action. It means through the use of clicks or scroll, you're able to tell if the user is going to do something. On our homepage, we have an infinite load feature, which means that as the user is nearing the scroll of the feed, we fetch new data and append it to that. And a usual technique is to use a scroll handler and just read the scroll position. But using intersection observers, you can connect to the middle of the feed and get and observe that element. And when it comes into view, that's when we fetch the module. And the module itself, it's using a similar technique where it just adds, it observes the last element of the feed, but with a really high margin up in order to do the fetch and then append those elements. You can also use progressive enhancements. This is a term usually used to the use of polyfills on older browsers to support new features, but you can look at a feature and also see what is the critical requirements of this feature. Anything outside of that is an enhancement. We have an example, we have a search modal that when you start typing, it has a type ahead feature. So if we narrow down the requirements, it's very critical that the user is able to open that modal, start typing, and getting search results. At that moment, the type ahead becomes an enhancement. So we separated the logic that deals only with opening that modal, and the type ahead is a separate module. And then we realized that really, to open the modal, we were just adding a click. So we used my favorite JavaScript technique, which is to delete it and do it in CSS. We use the CSS target by looking at the URL. If you look at the URL, you see that it changes when I click the bottom. And this means that we can disable JavaScript and the user is still able to open up the modal and start typing. And the type ahead, if you're on a fast connection, it will start working as you start typing. And we kept the click event that was there before, that it was adding a class to show the modal, but we kept it for the only purposes of loading the module and then removing itself after it loads. And this is how, after applying this across a ton of modules, this is how we fare after. Our homepage bundle went down to 27 kilobytes. Under the same conditions, it was loading on 220 milliseconds. And that bubbled up to our sites loading at slow as 2.5 seconds. So that's pretty great. To put that in context, that's 4 seconds faster of first contentful paint. This is what a video of before. We start seeing something pop up at like 6.5 seconds. And we are visually complete at 13. And this is after. Things start popping up. And at 3.3 seconds, we're visually complete. And this made other issues that we already knew when we were considering optimizations, like using font display for the fonts and switching our icons to from icon font to SVGs. But these are concessions that we made in order to focus first on JavaScript. But it was still weird to see all of this white space there, so we had another change to add a background with a loader in order to improve that perceived performance. This was great for the first contentful paint, but we were still seeing in some tests our time to interactive skyrocket, where we would ask, why is it still slow? I thought that you fixed it. And to answer this question, we have to talk about first party versus third party. First party is all the scripts that you can control, and third party are the ones that you can't. This is the waterfall of that 2.5 seconds. The ones at the top, colored green, were 11 requests of us. Then the tag managers comes at the 7th request, which loads all of our third party for a total of 125 requests. And besides of the amount of this request is the inability for us to optimize those scripts or to be able to prefetch them or preload it because they change every single time. So when we were getting the question asked, why is it still slow? The answer was pretty clear. And after this, it felt like optimizing performance was going like to the dentist. Most people would agree that it's an important thing to do, but then everyone just avoids it as much as possible. And no matter how much you brush, floss, or use mouthwash, nothing is going to change if you keep eating candy. And for us, third party was our candy. And we couldn't just get rid of it or defer it because it would directly affect our revenue, which was the one thing that we talked about with our executives. Looking back to this time, we focused on delivering results, which was both good and bad. We went heads down and we got stuff done, but we didn't communicate clearly to everyone else. So the teams really felt like this was a top-down decision. Like suddenly the bosses said, we're gonna focus on performance, and they were like, okay. And the question kept coming up, how fast is fast enough, right? You see time from 13 to 2.5, that seems a lot. So are we done? And the answer is never, right? There's always stuff to improve, and we were still pretty slow on slow 3G or really old Android phones. So we asked ourselves, what if performance is part of the development process? Which leads me to the second point, that is the conventional path to tackling performance of developer awareness. Over the last couple of years, we have seen the role of developer advocates grow, and conferences and workshops grow because this stuff is easy, right? We just need to learn a couple 100,000 things to make our sites faster. And unlike the backend, this stuff seems to change every single day. Best practices like bundling everything in one file on HTTP1 to not generate another request become anti-patterns because of HTTP2 and its stream ability. So the problem with performance is that it depends who you ask. It can mean separate things. So we decided to take the same approach that most performant algorithms do and divide and conquer. We split performance in 3 different tracks. Server to deal with our APIs and caching and other strategies. Application to deal with HTML, CSS, fonts, and also accessibility. And development to deal with our build speeds, continuous integration, bundler and configuration, and all of that stuff. And with each one of these areas are potential bottlenecks. This is a comprehensive list of all the different things that triggers, that force layout in JavaScript. And as you start learning this stuff and you start bringing it in code reviews, it can be pretty overwhelming to your peers. So the question that you need to ask is not why are you using this, but what do you intend to do? The more that we focus on what the goal is, the less that we start demonizing certain methods or certain strategies. And the more that you ask this question, you start seeing patterns show up that lets you abstract those optimizations into things that the developer doesn't have to even think about. And I wanted to talk about get bounding client rect. If you are not familiar with this, it's an amazing method. It has been around for a long time, since IE5. And what it does, it gives you the coordinates of where an element is on the page, regardless if it's positioned relative or absolute or fixed. And it gives you its top, left, bottom, and right values, and it's the most precise. But it's a problem. It's in the list that forces layout, right? And that means that the browser has to drop whatever it's doing right now, go to the render steps to be able to give you that information. So if you put it on a scroll handler, you can have a really bad time. You can use request animation frame to defer it, but there is a problem that if a request animation frame is changing the size of that same element, then depending on the order, the other one that is reading it would also go back to the render steps. Which brings me back to the intersection observer. While I was doing the infinite load technique of getting the middle element, I found out a couple of things. When you observe an element using the intersection observer, the callback fires right away, not only when that element is in view. And another thing is that the entry has this information, the bounding client rect information. So knowing this couple of things, we're able to create our own asynchronous get bounding client rect by creating an intersection observer kind of like on the fly and getting that data. This is like being asked to be notified about the next update of the frame. And you'll most likely miss one frame, but for most cases, this is fine and not noticeable. Another optimization is that we automatically, on touch devices, we change clicks to touch start. This increases our perceived performance by 100 milliseconds. And 100 milliseconds may not seem like a big thing, right? And so a question that the developers kept saying is it worth it? If this is not even noticeable, is it worth doing it? And I have to go back and address your comments from a code review. And so we decided to draft some questions when performance was a blocker on our code reviews. And those questions were, is it part of the critical path? Which means, is your code executing while the page is still rendering? Then yes, you should address it. How frequent will it run? Are you doing a loop that could have a really large set of data? Or is this an interactive component like a date picker? Then it needs to be really responsive. And is it a share or base component? And this one is the biggest question because this one is not measurable, right? You can measure everything else by how milliseconds it took before and after, but this addresses the problem that when something is merged, it becomes the truth. And if you build something only thinking of the current feature, someone else is going to look at that code and assume that it went through all the reviews, it's ready to be able to reuse and expand it. And development is really like a game of telephone, where you just need one person to change something slightly and it can become a whole different thing. Looking back on this time, developers were challenged by constraints, which again was good and bad. Some developers really enjoyed the challenge of doing more with less, while others just felt like we were slowing them down, which reflected on features taking longer to finish. And education without immediate action was quickly forgotten. I feel like I presented last year, I talked about performance internally, nonstop. And a couple of weeks ago, I noticed that in one of our Slack channels, there was a conversation about React Lazy. And one developer that assisted all of my presentations asked if this was noticeable or if it does improve performance. And it's not like he was oblivious to all of my presentations. It's just that he thought that code splitting was a Webpack thing. And this, if you notice, each one of this can be fixed, right? Like, we could always hire performance-focused engineers and people that enjoy doing more with less. You can make a case to your business that the features that are building are slower but safer and faster. And you can invest a lot in education internally and also send all your developers to conferences. So at this point, I really felt like, so now what do I do? Is that it? And last year in June, I saw the talk by Lauren Younger of how to manage performance like a feature. And this image really impacted me because at Hearst, we have the same roles, but I've only been focusing on two, engineering and management. And I realized that I do need the cooperation of all of these people in order to achieve my goals. And that leads me to a third path that is not usually talked about, of product and design. This is our life cycle. We have an idea, so someone pitches an idea, it goes into a prototype, then we test it, then it goes into development to an MVP, and then we optimize. And we think that this is where development should happen, because anything before that is not real. It's not a thing yet. But this is really where it should happen, because we have the scenarios where a prototype is really successful, and it just becomes frustrated that when something is working, it's not in production until months later, right? But the pushback that I got was, I'm just moving the slow development that I was introducing with code reviews now to the idea level. But we don't have to handle all of the performance optimizations at this point. So I asked, could performance be affecting your hypothesis? Could something that you could have performed better if it was faster when you were testing it? And they told me, well, we accounted for it during testing. We're just trying to get a signal that if something slow does good, then it's just going to get better, right? And it kind of makes sense, but features are not isolated. There's all this stuff loading at the same time that could be preventing your feature from loading faster. So we devised performance paths. We asked, why are we doing this? And we're able to align best practices with goals. We can able to split performance even more to render or runtime performance, or mobile versus desktop, depending what your goals are. And this is the chance to share specific knowledge. For example, if you have a render ticket and that your goal is to improve your SEO, there's a couple of things that you can see. How does your markup size increases, and how does that affect your time to first byte? And that can prescribe some optimizations. You can reduce DNS lookups or do pre-connects. You can use semantic HTML elements. You can use regular URLs instead of hashes. If you're building a single page app and you're using hashes, the bot is going to ignore them. So use regular URLs and use the history JavaScript API. And if you're doing a lot of internal APIs, consolidate them with GraphQL and do resource-based caching. And all of this is great to plan for today's problems, but how can we prevent from blocking ourselves tomorrow? We generate this tech debt, but tech debt is not really bad code. It's just a decision that we make about tomorrow, today. So what is one question that will help us understand the problems of tomorrow? Is ask ourselves, what if we're building rocks? What if it exceeds our expectations? Share the vision. Share where you see this feature growing and eventually being. Knowing that, you're able to document every trade-off. You're able to specify reasons. Is it by design, or is it a technical limitation? Because as the technology improves, you're able to look back and address something that you were not able to do before. And this would be something great if open source packages could do, of listing non-goals. So it would reduce the amount of issues being created that are outside of the creator's intent or scope. And once you document them, you can plan them. You can describe the scenarios that it would block, and you can prevent told you so moments between coworkers. And the biggest thing is the mentality. It's that you don't have to build to enable it. You don't have to abstract early or over-engineer. As developers, we can leave ourselves clues into the code to know where we can move forward. Or if we buy into a pattern, how can we revert that pattern and move into a separate direction? We can all imagine that. Now, this is not a time to imagine how your code will look or work when the machines take over. So don't go down a rabbit hole. If you need to do it, time box it to an hour or a day. And the lessons learned. Oh yeah, and you're all caught up now. This is what I've been doing for the last year. The lessons learned, a temporary manual setup is crucial to progressively refactor an application. A Webpack config usually advocates to package everything in one Webpack config, but depending on the usage, you can progressively refactor modules that are using the dependency of your dependency in order to move faster. We found out that our legacy application was using backbone underscore, and jQuery is a dependency of backbone, but some modules were using more jQuery than backbone specific things. And our backbone bundle together was 81, but jQuery itself is 86, so we're able to split that. Customization is key. Webpack doesn't allow for multiple performance values for your modules. You're able to use the filtering to exclude legacy, but that's not really great because then it becomes just the Wild Wild West, right? So it would be great if we would be able to do this. A solution is that you can have multiple configs, but that requires bigger effort, and then you have to look into parallelizing those builds, and then we wonder why companies don't invest in performance. And performance budgets are great, but it's rarely a single pull request. For us, it was just addition of someone being like, well, it's just 3 kilobytes, good. So just merge it in, and then that repeating. And as we improve our continuous integration, we could have the scenarios where we just have a great storm of PRs going at the same day, and by the end of the day, our budget is blown. So I was thinking, how can we predict regressions? Last year, I built this little tool called Spotter, and what it does is it looks at every open pull request, and it tells you other pull requests that are modifying the same files. That way, if you can proactively communicate with other developers and check if they're removing or modifying a function or any other functionality that you are depending on. And wrapping up, what should we do if we care about performance? Don't stop at tools or techniques, but how they fit into a process. This might be a process that you don't have or a process that you need to create. And how do we get our colleagues to care about performance? Make tools intuitive and digestible. This is a picture of the Wikipedia engineering team in 2015 addressing their performance millisecond by millisecond. And I used to look at this and think, wow, that's hardcore, that's advanced, that's what I want to do. And now I look at it and I see the opportunities of making our tools interactive, not only for ourselves, but for our remote workers. Which leads me to my final point. If you are not familiar with these initials, they stand for developer performance. And I feel as we have increased our development tool chain, and we start, and we put HTML and JavaScript, then CSS, then your house, and then your mom, we are moving away from the other disciplines that are critical to our development. And the more that we put in ourselves in someone else's shoes, the more insightful tools we're going to build together. Because performance culture is more than code. You can have the fastest site out there and you still don't have performance culture. Or you could have the slowest site at this point in time and you could have performance culture. Because it's not about fast or slow, but the choice to wander out in tackling competing priorities, but having a clear path back. Thanks for listening.